All right, now we're on to the last way of getting the information we need to sketch a quadratic. So remember the three pieces of information were y-intercepts, x-intercepts, and turning point. So the last one, the last way of getting that from general form is using the quadratic formula, which is a formula that will take you straight to the x-intercepts. Now, I'm not going to show you where it comes from, but I'll do it at the end. So if you want to see where it comes from after the last example, stick around and I'll show you a bit of fancy maths. So the first thing for quadratic formula is to remember that this quadratic is written in the form that looks like this. All right, so we can see there that there is a coefficient of x squared, there's a coefficient of x, and there's a constant there. What we need to do, first of all, is to match up the information in the quadratic we've been given with the information in general form here. All right, so I'm particularly interested in what a equals, what b equals, and what c equals. So we can see from general form that a is always the coefficient of x squared. So in this case here, there's a. If nothing is written, we know it's 1. B is the coefficient of x, and so b is here, and so b is 4, and c is always the constant, and in this case c is 1. Okay, so your first step is always to write down what a equals, what b equals, and what c equals. Then, and don't get overwhelmed by this, I'm going to write the quadratic formula here to the right hand side. X equals minus b plus or minus the square root of b squared minus 4ac all over 2a. So the part we're interested in is the right hand side of the equals sign. This is what we're finding, and you can understand that to mean the x-intercepts. So we need to know b, a, and c, and I'm going to rewrite the quadratic formula here, and then we're going to substitute what we know into the form. All right, so minus b. So I'm going to use brackets in case we have negatives, plus or minus b squared is 4 squared minus 4 times a times c, all over 2 times a. So now it's looking a little bit more friendly, but we do have to simplify. So minus 4 plus or minus the square root of 16 minus 4 all over 2. So you can see that I've just multiplied the brackets out and squared what I needed to. I'm going to move to the right. Next step is minus 4 plus or minus the square root of 12 over 2. And at this point, I could say to myself, that's where the two x-intercepts come from. Or if I wasn't interested in sketching, I could just leave it like that and say, this is my solutions or my x-intercepts. So my two solutions are minus 4 plus root 12 over 2 and minus 4 minus root 12 over 2. So you can see that if I was asked to sketch, I would just have to label where those points were on the graph. Because 12 is not a perfect square, I don't have to evaluate it as a decimal, I leave it as a third. And that's probably the best way to do it. What you might notice though is that this could also be simplified one step more by splitting up the fraction to look like that. And the reason we might want to do that is because we notice that we can evaluate minus 4 over 2. Minus 4 over 2 is minus 2. So this could become minus 2 plus root 12 over 2 and minus 2 minus root 12 over 2. And this allows you to identify where the x-intercepts are a little bit closer. You know that it's centered around minus 2 because that's the constant in both x-intercepts here. So minus 2, and then you go a little bit to the right with plus root 12 over 2 and a little bit to the left with minus root 12 over 2. If you were interested in simplifying your surds, remembering that skill that we learned at the start of the year, you might remember that root 12 can be written as 2 root 3 because root 12 is made up of root 4 times 3, and you're allowed to split out the root 4. So it could become something along the lines of 2 root 3 over 2, and you might then go, oh, I can simplify out the 2's, so this could become minus 2 minus root 3, and this one at the top would become minus 2 plus root 3. And the benefit of that is it allows you to identify the x-intercepts a little bit closer. All right, so if we graphed these x-intercepts here, we might not know how far left or right to go from minus 4, but when we graph these ones, we know, okay, so it's at minus 2, and then root 3 is only just a little bit bigger than 1, and so I'm going a little bit more than 1 left and a little bit more than 1 right. And I can pretty accurately graph those. All right, so to recap, this is the quadratic formula. Minus b plus or minus the square root of b squared minus 4ac all over 2a. Key information is the coefficient of x squared, which is a, the coefficient of x, which is b, and the constant, which we call c. Once you've identified those, you need to substitute them into the quadratic formula in their relevant places and simplify, 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 simplify until you end up with the simplest form available, which some of the time will have surds, some of the time won't have surds, depending on whether or not the number under the square root sign is a perfect square or not. So in your books, you need to have written down the quadratic formula. You need to have an example like this annotated along the way. So you might, when I say annotated, you might want to write step 1, ID, A, B, and C. All right, and then step 2, sub in A, B, and C. Okay, particularly important that you do that process of writing your notes and annotating them, because that is how your notes become useful in the future. So I'll let you go and practice now. For those who want to see where the quadratic formula comes from, stick around and I'll show you.